In this video, I'll be summarizing 7th grade Unit 4, Lesson 7, 100%. So today, you're going to try to use a double number line diagram to help solve percent increase and decrease problems. We're going to really focus on that 100%. So the original amount is always the 100%. And we are going to try to figure out the original amount if you know the new amount and the percentage of increase or decrease. So let's start with the more basic problem. A box of cereal has 500 grams, and then the size decreases by 40%. How much cereal is in the new box? So in this time, the original amount is 500 grams. That's going to represent our 100%. When you're trying to create a double number line, you want to think about nice scales. So in this case, because I need to go down by 40%, I might want to count by 20%. So if 500 is 100%, then 100 is 20%. So we can divide by 5 to get there. If we know that if the size decreases by 40%, notice we're starting at 100%, we decrease 20%, another 20%, we go down to 60%. So 60% of the price is a decrease of 40%. Therefore, there are 300 grams of cereal in the new box. All right, when you're solving problems about percent increase and percent decrease, it's very, very important to start asking yourself, what is 100% in this situation? Because then you can find a percentage of that amount. So we're going to look at a few where we don't automatically know what the 100% is. So here's a scenario. After a 25% discount, the price of a shirt was $39. So that $39 is not the 100%. It's our price after a 25% discount. So I want you to think about that. We started at 100% and we have a 25% discount. We are at 75%. So that 75% is my $39. We're trying to figure out what the price was before the discount. So we're trying to figure out what that 100% is. So there are a few ways to solve this problem. If you're trying to do it mentally and using number sense, I think it's probably easiest if you scale it down. So if we look down to get from, say, 75% to 25%, that's dividing by 3 or multiplying by 1/3. So we can do the same idea here to get to the 25%. 39 divided by 3 or times 1/3 gives us $13. So it's $13 for 25% of the shirt. And then I want to scale it up to get to 100%. So I'm going to go here, times 4, times 4. And we can get that it's $52 originally. So this is a good strategy, mental math-wise, to be able to figure out something independently. All right, this time it's just a blank. Okay, this problem. There are 20 students in a class. This is a 25% increase from last year. How many students were in last year's class? Okay, this time, is that 20 students the original full 100%, or is that something different? Okay, I want you to notice it's something different. That's after a 25% increase. So if I start filling out my double number line, it might be making a lot of sense to count by 25%. And after I get all the way up to 100%, I need to still keep going because I need to increase it by 25%. So I'm going to go all the way up to 125%. That 125%, that is what is represented with 20 students in the class. So if I'm trying to figure out this problem, I can do it in a couple ways. I can figure out straight the scale factor from 125% to 100%. So that would be in one step. You could do 100 divided by 125. And notice that's 4/5 of the price, or actually of the students. So we can do the same thing here, 20 times 4/5. And that's going to give us 16 students. So there were 16 students in last year's class. If you didn't want to do that, you could go all the way down to the 25%, divide 125 by 5 to get there. So again, divide 20 by 5 to get to 4, and then count up on your chart to get to the 16. All right, these problems are relatively tricky, so really it's just important to look at that 100% and see where you're going. Go ahead and look at the goals and see if you have any questions.